Tonight, we're talking about the interesting and generally controversial topic of wolves and deer and how that translates to deer hunting and what wolf management would or wouldn't do to change the dynamic between wolves and deer. I did want to note, so this originally the first web version of this webinar a couple weeks ago was sort of the first webinar in our winter webinar series. We have two more webinars left in our winter webinar series. We have one on March 18th entitled Are Wolves Ecosystem Saviors? And if not, what ecological purpose do they serve? That's really focused on examining how do wolves have an impact on large ecosystems by hunting and killing prey? There's obviously been a lot of work that's come out of places like Yellowstone National Park, some of which has suggested wolves can have very large ecological effects. And then there's a lot of recent work that's suggesting maybe that's really not reflective of the role that wolves play in ecosystems. So we're going to go through that topic and then also talk about the work we've done in our area to examine some of those ecological roles of wolves and what we can learn from them. So that's on March 18th. And then on April 9th is a webinar by Austin Homkes entitled What a Year on the Voyageurs Wolf Project Actually Looks Like. Many folks follow us on social media, and obviously we share some of the highlights or the really interesting things that we come across or that we're doing at any given time. But that's not necessarily reflective of what it actually looks like to be on our project and on a day-to-day basis. And so the hope here is to kind of walk through what a typical year looks like for us and what are we doing, what kind of field work does that entail. So if you really want to kind of understand what it actually is like to be a wolf biologist and to study wolves, that'll be a great webinar. So for both of these webinars, you do have to register, and there's links on our social media, or I can share a link at the end here if you want to register for either of those. So before I get on the topic of wolves and deer specifically, I did want to provide a brief overview of our project in case there's anybody who's not super familiar with what we do or with our project. So we're a University of Minnesota research project, and we've been studying wolves actually for a little over a decade now. So we've been studying wolves since 2015, and our emphasis has really been on trying to understand the ecology of wolves from spring to fall. That is a time when it's been traditionally very difficult, or at least historically, I should say, very difficult to study wolves because without GPS collars and trail cameras, it's very hard to understand how wolves are moving across the landscape and to be able to actually observe them. So, so it's been a time that we were really interested in. Luckily, our project started right as sort of new technology was becoming available, and so we were able to take advantage of that and try to really understand aspects of wolf ecology that really hadn't been studied before. Our overarching goal on the project is to couple cutting edge, rigorous wolf research that's novel, really informative, with also highly effective outreach and education through social media and webinars like this. We study wolves in an area that's called the Greater Voyageurs Ecosystem. That's shown here by this yellow outline. And then in the northern part of this system is Voyageurs National Park, which is this white outline here. And then just across on the north side of Voyageurs is Ontario, Canada. So that's right up here. In this map, each one of these polygons is a different pack territory. As you can see, our area is saturated with wolf packs. So we have a very high density wolf population in and around this area. One thing I did want to point out is a lot of times people assume that our work must be really focused on Voyageurs National Park, and therefore our results are not maybe reflective of what's going on outside of a national park setting, as national parks are obviously managed very differently than most land. But actually, the majority of our study area is outside of the national park, as you can see here. And given the sort of oblong, kind of interesting shape of Voyageurs, you don't have many packs that actually exist solely within the boundaries of the park. You maybe have a couple of packs here, but all the other packs are going in and outside of that park on a regular basis. And so that was actually one of our motivations to try to study wolves outside of the park well, because whatever's going on out here is undoubtedly going to be affecting wolves in the park and vice versa. So the focus for tonight's talk is to really get at the relationship between wolves and deer hunting based on the data that we can observe and analyze and look for patterns in. And then we're going to also examine whether wolf hunting and trapping would likely increase deer populations. Now, before I begin, I want to talk a little bit about my own background because often when we start talking about this issue of wolves and deer, it can become a very controversial topic, and how you fall out on whether or not you think wolves are or are not impacting deer becomes in essence like a litmus test of how you feel about wolf management, wolf hunting, wolf trapping, and even your opinion, your political perspectives, and all sorts of things. And for us throughout this talk, the when we're talking about wolves and deer and whether wolves have an impact on deer, it isn't an assessment of whether or not we think there should or should not be a hunting or trapping season. It's trying to look at the data that's available and try to understand what patterns there and what does that tell us about the way the natural world is working. Oftentimes, as you're going to find out in this talk, a lot of the evidence suggests wolves are not really to blame for a lot of the changes you see in deer populations. And when we've shared that information, we're often accused of being an anti-hunting organization. We hate deer hunters. We've heard all sorts of things like that. We secretly have an agenda to basically get rid of hunting. And the irony there is, myself and many of us on the project have been lifelong hunters and really enjoy hunting. So this is sort of my background. This is me as a young kid. I got to go moose hunting with my dad in Newfoundland, and I grew up hunting and fishing. That's basically on both sides of my family. That was a very important tradition. I shot my first deer with a bow at the age of 12, and then this is a photo a couple years later when I shot another deer with a bow. So for me, growing up, opening day of deer season was almost like a holiday. It was something that was a really big deal and something that I looked forward to and something I still look forward to this day. So one of the reasons that I'm really interested in hunting is because it was a familial thing. In particular, uh, my grandparents on my dad's side of the family were both avid hunters, my grandma and my grandpa. And I'm very fortunate that my grandma and grandpa are still alive and they're still avidly hunting. So this is my grandpa. This is last fall. He's 92 in this photo. This is my grandma. She's 89. They both got deer last year hunting. And so I go back to Michigan, which is where I'm from, to go hunting with them. And so I think there's not many people who are 34 years old who can say they've gone and taken their 90 some year old grandparents deer hunting. So that's something that's very special to me. And I grew up hunting with them and my dad as well. In terms of our project, so our project when we started in 2015 was really myself and a guy named Austin Homkes. This is Austin Homkes right here. Austin and I met each other in undergrad at college, and we met each other and became good friends very quickly precisely because we shared a similar interest in deer hunting. That was the thing that really got us connected. That was the first thing we ever did together as friends. So this is Austin and I, 3 years before the Voyageurs Wolf Project ever was in existence, with an 8 point he shot on my family's property. And this is something Austin and I still enjoy doing to this day. This is last year or 2 years ago, some deer we got, and then this was this past fall as well. So the notion that we don't like hunting or that any of this talk is an affront to deer hunting is really quite silly. And like I said, I'm showing all this to simply point out that the same people that you see in all of these photos doing all of this work, making a lot of these scientific conclusions, are these same people who also very much enjoy hunting. That said, I understand that there's a lot of people who don't necessarily like hunting. I would be happy to have a discussion about that at a different time. But I did just want to provide a little bit of my background. So, what this talk is not, which is hopefully clear, it's not a talk or a statement for or against the merits or the values of wolf hunting and trapping. I'm going to come back to this point quite a bit at the end. But we did want to start off by saying, or I did want to start off by saying that the science is pretty clear. Wolf populations are very resilient to hunting and trapping. And I'm going to come back and talk about the data on that and why we can make that conclusion pretty safely. Now, for tonight's talk, we have a variety of different data sources. Some of the data is going to be from our project. We collect data on wolf populations and prey populations every year, and we have since we started. So we have data on moose, deer, beavers, and snowshoe hare, and then obviously we estimate the wolf population very intensively every year as well. We're going to be talking a lot about deer hunting data in the state of Minnesota and in other places as well. All of that is publicly available data that's collected by these state agencies and is publicly available on websites or via data requests, etc. But in the state of Minnesota in particular, every year Minnesota collects really high quality data on the number of hunters that are in each deer permit area, as well as the number of deer harvested per deer permit area. So that allows for some really fine scale analyses that allows to really look at how is hunting changing through time. Now, where we're going to be really focused on tonight is what's often referred to as the arrowhead of Minnesota, or really northeastern Minnesota. And that's kind of this chunk right here, which is basically from International Falls, kind of down through the Iron Range of Virginia Hibbing, down to Duluth, and then all the way up kind of the northeastern part of the state. And we're going to be focused there because this has been the area that wolves have sort of been in almost forever. It's the one area that wolves are really never fully extirpated from. And it's really been core wolf habitat, and it's really the core of the forested area of northern Minnesota as well. And then in this map, each one of these little areas are the deer permit areas that the state collects data for. Now, why are we even thinking about this topic recently? Well, the reason is that over the past handful of years, and then also over kind of the past decade and a half, as I'll show in a second, there's been declining deer harvests in northern Minnesota, and harvests have dropped considerably since the mid 2000s. And so, understandably, there's been a lot of concern of what's going on, what's causing this, and how do we reverse that. So this graph here just shows you, what that looks like in northern Minnesota. So in the orange line here is overall harvest, and then the yellow line are the number of bucks harvested. So we have the deer harvest on the y-axis and then years on the x-axis. And what we see is that deer hunting was pretty decent from 1980 to 1995. There was a pretty abrupt drop in the 90s. But then all of a sudden we see the deer overall harvest really start climbing, and the mid 2000s was really sort of the heyday of deer hunting in Minnesota. And then what we see is starting in about 2007, 2008, there starts to be this very sharp, precipitous decline in deer density, right? And then down in 2014 was one of the worst deer hunting seasons or deer harvests in the past 40 years. And then we've seen a little increase in the late 2010s, and then there's just been this decline, and deer harvests have still been quite low in the past couple of years. Now, one thing I want to point out though is so that graph I just showed is the total number of deer harvested in northeastern Minnesota. And often that's what you're going to read about in newspaper articles or magazine articles about deer hunting or sort of how the deer season was the number of deer that were harvested. But that's not really a great metric for looking at how good or bad a deer hunting season is. And the reason why is that the number of deer harvested is going to be strongly related to the number of deer hunters that are actually out there in the field. So obviously you have more deer hunters, you're going to have more deer harvested. So I illustrated this just by looking at the number of deer harvested per deer permit area in northeastern Minnesota over the past decade. And each one of these different colored dots is just a different deer permit area. And again, the point here is that as the number of hunters increases, which is the y-axis, the number of deer harvested also greatly increases. So if you have changes in the number of deer hunters, you would expect to have changes in the number of deer harvested, even if hunter success rates haven't changed at all. So the reason this is important is that the number of hunters in Minnesota and across much of North America have been declining as time goes on. And you can see that when we look at the individual deer permit areas in northeastern Minnesota, which I'm showing here. Each one of these graphs is a different deer permit area. And in these graphs, the blue trend line is the number of hunters that are in that deer permit area each year. And then black is the number of deer harvested. And you'll notice a similar pattern. And that pattern is that the number of hunters is decreasing in almost all of these deer permit areas, and in many of them decreasing quite precipitously. And as you see that decline in hunters, you also often see a decline in the number of deer harvested in many of these areas. So really you have to account for the changing number of hunters if you want to really understand how deer harvest is changing. And less folks think that this is unique or special to northern Minnesota. It's really not. So this is the pattern in all of northeastern Minnesota. If we sort of put all that data I was just showing you together, this is the trend in the number of hunters through time. All right, and so like I said, there were fewer hunters in the 1980s, and then there was a really big increase. And in the 2000s, early 2010s, that's when there was the most hunters. And then there's been this really steep decline over the past 15 years or so. But like I said, that's not unique to northeastern Minnesota. There's the same pattern going on in this is northwestern Ontario, right across the border from us. Canada collects really good data the same way Minnesota does. There's been a 70, almost 70% decline in the number of hunters in the past 15 years. In the Upper Peninsula of Michigan, we see a similar pattern starting in the 1990s. There's basically been just a steady decline of the number of hunters in the UP. And then there was actually a paper published just recently on basically the projection of how the number of hunters is going to change in Wisconsin. And what that study found is that absent unforeseen changes, the decline in deer hunter numbers will continue and will present major challenges. And this isn't just a decline of deer hunters in wolf range because there's wolves, which is sometimes what people will tell us. It's all across the state. So this is a large issue that's happening that's not restricted just to places where there's wolves. Now, a better way, as I kind of alluded to looking at how harvest is changing through time, is to quantify hunter success rates, which is the number of deer harvested per hunter, because this is sort of a standardized metric that accounts for the differences in changing number of hunters, and allows you to then compare, let's say, the mid 2000s to current times a bit more accurately. And so that's what this graph is. This is showing hunter success rates. I went through DNR data and kind of put it all together. And these are hunter success rates going back to the 1980s. And what we'll see is that in the 1980s, hunter success rate was pretty good. Then we had a pretty sharp decline in the 90s, and then it steadily rose. And then it was really high for several years in the mid 2000s again. And then we saw this decline, then a little increase, and then a decline. But the thing that's worth noting is this sort of increase and decline is not quite as substantial when you account for the changing number of hunters than it was when you look at just overall harvest through time. But nonetheless, deer hunter success rates have definitely decreased through time. Okay, so now we're going to zoom in to the greater Voyageurs ecosystem and the deer permit areas that are really around or sort of adjacent to the greater Voyageurs ecosystem to try to look at patterns of wolf and deer dynamics as well as how that translates into deer hunting success rates. Now, for this assessment, what's important to note is we're going to assume that the wolf and deer populations in our study area, the greater Voyageurs ecosystem, are representative of wolf and deer populations in these deer permit areas that are in or adjacent to the greater Voyageurs ecosystem. That doesn't mean that we are assuming that they're identical, the density of deer is the same throughout. Rather, what we're assuming is that the trends, the way that these populations of wolves and deer are changing through time, are similar across this wider range. And we think that's likely a pretty fair assumption given its similar habitat, similar land use patterns, similar weather, similar predator composition. So there's not a lot of reasons to think it would be dramatically different outside of our study area than inside of it. So the first question we wanted to answer is what drives deer hunter success rates in the greater Voyageurs ecosystem? So what we examined were our estimates of the deer population in the GVE, which is this purple line, and then looked at hunting success rate changes in the greater Voyageurs ecosystem. And what we see is that from about 2015 until 2022, these mirrored each other very well, indicating that our deer population estimates were a pretty good approximation of deer densities in our study area. The only year that we saw a little mismatch was in 2023 when we actually saw hunter success increase a little bit when the deer population actually declined pretty precipitously per our estimates. 2024, we actually saw a little increase though in the deer population, and that was reflected in hunter success rates. I'm going to take this data now, and I'm going to put it in a linear graph to kind of show the linear relationship between these two. And this is what we end up seeing. So we've got this pattern here where we've got basically a positive relationship between deer populations and hunter success rates through time. So basically, as there's more deer, hunters are more successful, which I'm sure is not really going to surprise anybody. So the key takeaway is hunter success is driven by deer populations. Now, what about the relationship between wolves and deer? Well, what we often hear is occurring from some individuals is that the wolf, that as time goes on, we sort of have this relationship like this. The wolf population continues to increase sort of indefinitely or just in perpetuity. And while that's occurring, the deer population is just declining and getting smaller and smaller. So, in other words, if we took this relationship and we put it into sort of statistical terminology, we would say that there's a negative correlation between wolf and deer populations. So as wolves go up, deer go down, and vice versa. And the reason I'm kind of framing it like this is that's something we can examine with the data that we have. So this graph here shows the trends in the deer population and the wolf population in our study area. So deer are in the bluish purple here, and wolves are in the yellow. And what we see here is also another interesting pattern, which is from 2015 to 2000 and basically 21, the wolf and deer populations were really kind of in sync with one another, and wolves are really kind of following changes in deer populations. But then what ends up happening is in 2021, we see this relationship really take a pretty interesting turn. And what I mean by that is wolf populations in 2022 actually increased, wolf density increased, but deer density decreased, and then it decreased again in 2023 pretty precipitously. But in 2023, the wolf population remained stable. And what's really interesting to note here is that 2022 and 2023, those winters were extreme winters. And I'm not using extreme as my subjective assessment. That's how like winter severity indices would classify them as extreme. So we had these two back-to-back extreme winters. And that really seemed to throw this relationship sort of out of whack or out of sync. And so instead of, wolves following the deer population, what ended up happening is the wolf population remained fairly elevated, and then the deer population was really low. Now, what's happened since those two severe winters is that the wolf population has declined quite a bit because we have much lower deer densities, and there's just simply not enough deer to support a wolf population of this size. And so we now see the wolf population sort of adjusting to changes in the deer population. Now, you might be wondering, why did this pattern occur? And what's likely happening is once there's a severe winter, wolves come out of those severe winters in really good physical condition. They've basically been eating deer pretty consistently all winter, putting on a lot of body fat. So they're going to be coming out of those harsh winters in really good shape. Deer and deer population, on the other hand, are coming out of those severe winters or extreme winters in really poor physical condition. A lot of deer died during those winters, and the ones that made it are going to be probably in really bad condition. They might have survived, but they're not going to be in good physical condition. And so so there might be fewer deer on the landscape after a severe winter, and they might be in poorer condition. But wolves, once the spring hits, they now also have another really abundant food source in our area, and that's beavers. And some wolves in our area will get 50, 60, up to 80% of their biomass that they're killing every winter or every summer will come from beavers. That's not every wolf, but wolves do get a lot of food from beavers. So even if there's low deer densities from the severe winter, wolves aren't going to immediately feel that effect because in the summertime they're going to be able to take advantage of other foods. Now, what happened here is we had one severe winter, wolves were able to kind of then weather the next summer, and then there was another really severe winter again. And so now you have deer that are in poor condition once again, and wolves are going to be coming out of that winter again in good condition. Except there's only so long wolf populations can persist with really low deer populations before the wolf population is going to inevitably kind of show the effects of that reduced density of prey. And so that's exactly what we start to see here is that once we got out of these severe winters, wolf populations are having to adjust pretty considerably to now match that reduction in the deer density on the landscape. Now, another way we can look at this pattern is looking at the linear relationship between wolves and deer populations. So this is the same data as this previous graph, but just displayed looking for some positive or negative correlation. And what we see when we look at this is a generally positive correlation between wolf populations and deer populations. That is, when there's more deer around, there's generally more wolves and vice versa. So this doesn't match the pattern or the correlation that some have suggested is going on, which is a negative correlation between wolves and deer. Now, what's really interesting too when we look at this data is we have to look at this pattern before and after those two back-to-back severe winters. And so we can see right here, these are the two severe winters. And then obviously this is the year that followed them. And what happens is if we take out this data after these two severe winters, what we can actually see is how closely the wolf and deer population were actually tracking one another up until those severe winters. So these are the 7 years before that. And what we see is a very strong linear relationship between wolf and deer populations, which again is indicating that as deer populations went up and down, so did wolf populations. They were very much adjusting, or wolf populations were very much adjusting to the change in deer on the landscape. Another really interesting way that we can look at differences, or at least the dynamic between wolf and deer populations, is looking at the deer to wolf ratio. So how many deer are there per wolf on the landscape? And that's what this y-axis here is showing, is the deer to wolf ratio. And this is through time. And what we see is for the first, 7 years here, that on average there was about 60 to 70 deer per wolf in our system. But then again, we have these very two severe winters, and that really drops this deer to wolf ratio and drops it really considerably. And by 2023, that ratio was under 30 deer per wolf. And that clearly was a ratio that was untenable for the wolf population because the wolf population declined. And now we actually see this ratio starting to increase again because the deer population is starting to rebound a little bit and the wolf population is coming down quite considerably. And based on all of the evidence this year, when we get our 2025 estimates for deer populations, we suspect that this number will probably be back up in this area somewhere around here. So the big takeaway, though, from our work is that generally speaking, when deer populations are high, wolf populations are high, and vice versa. Or put a different way, wolf populations are being driven by deer populations, not the other way around. Now, ultimately, that's not that surprising to us as biologists. Predator populations are often driven largely by the abundance of their prey, and that's true of most animals. Most animals are going to be largely, the number of them on the landscape is largely going to be a function of how much food is available for them. With predators specifically, there's a whole sort of sub-discipline of ecology that's focused on trying to understand predator-prey dynamics, and in particular, how predators respond to changes in their prey. And this is called the numerical response. That's what ecologists call it. And there's all sorts of theories and mathematical analyses to try to understand the relationship between predator and prey populations. Now, with wolves specifically, there's been some work done to really try to understand what governs how many wolves are on the landscape. And in 2014, there was a meta-analysis by McRoberts and Meach. And that meta-analysis, what they did is they took estimates of wolves and prey from all over North America, from a bunch of different studies, combined it and did a single analysis to see what governed the number of wolves in different places of North America. And what they found or concluded was that our findings indicate that wolf density is regulated by prey biomass. And prey biomass is just another way of quantifying the amount of prey on the landscape. So in essence, what they're saying is wolf density was really a function of the amount of food on the landscape. And this is actually the graph from their study, and there's actually an additional data point added, and this was published in another follow-up paper by Meach and Barbara Meyer in 2016. In this graph, we have on the y-axis the number of wolves per 1,000 square kilometers. That's wolf density. That's how wolf density is usually measured. And then on the x-axis, we have prey biomass. And prey biomass here is essentially just a measure of how much food, how much prey is on the landscape, and it kind of accounts for the fact that different prey are different body sizes, so how do you kind of standardize that? And so it's trying to account for different sizes of prey and then come up with equal comparisons between an area like Minnesota where there's deer and a place like northern Canada where wolves might be preying on moose. And so they convert everything to prey biomass. But when they do that, again, what they see here is a very strong linear relationship between prey biomass and wolf density. And what they actually found specifically is that prey biomass explained 81% of the variation in wolf density across North America. So essentially, if you know what the prey density is in an area, you could pretty closely approximate what the wolf density is likely to be in that area based on this work. So now it's time to look at the interesting question of how are wolves connected to deer hunting success in the greater Voyageurs ecosystem? Now, before we kind of dive into this, I want to just kind of recap and put all of this together. So what we've seen so far is that hunter success increases with deer population size. We also see that wolf populations also increase with deer population size. So ultimately, what we've found is that hunter success and wolf populations are both driven by the same thing, which is deer population. So they both go up when there's more deer around. So it should come as no surprise then that when we look at hunter success rates in the greater Voyageurs ecosystem, which is on the y-axis, and then wolf population density on the x-axis, that we see a generally positive correlation between hunter success rates and wolf population size. Now, when we first shared this a couple years ago, some people got very upset at us for suggesting that, there's better hunting when there's more wolves around. But what's really important to note here is we're not saying that wolves cause better deer hunting. That would obviously be ludicrous. What we're saying here is that generally, when there are more wolves around, that is a symptom that there are more deer around, and that's usually a symptom that the deer hunting is better. So wolves are simply a symptom of better deer hunting. They do not cause better deer hunting. So then naturally, this leads us to the question, if there's not evidence that wolves are driving changes in deer populations, then what is? And why are we seeing these large declines in the number of deer hunting or deer in the landscape, deer hunter success rates over time, deer harvest over time? What's causing that to decrease so substantially over the last 15, 20 years? And the primary factor that's really driving these changes in deer populations and deer hunting success in northeastern Minnesota are undoubtedly winter conditions. And I'm going to walk through precisely why we think that. Oftentimes when we've said this, oftentimes people think, blaming the decline on deer for winter conditions is just sort of a scapegoat to not make wolves look bad. For us, it really has nothing to do about making wolves look good or bad. It's simply looking at the data and assessing the trends in that data and what those trends really tell us about the way the world is working. And so I'm going to share that data and why we've reached the conclusion that it's ultimately winter conditions that are causing these declines. But first, we need to take a second and talk about how do we measure winter severity. So a lot of work that's done in Minnesota and other states uses a winter severity index that is often done by the Department of Natural Resources in those states. In Minnesota's, they have their own WSI. It's called the Winter Severity Index. If I remember correctly, I think that's the number of you get a point each day that the day is below 0 degrees Fahrenheit, and I think there's 15 inches of snow on the ground. That gets a point towards the Winter Severity Index or something like that. So that's one way to measure winter severity. We think that is probably a little coarse and doesn't really capture all of the nuances that are associated with winter severity and the longevity of winters. So instead, we use an index called the Accumulated Winter Weather Severity Index. And this is published by the Midwestern Regional Climate Center out of Purdue University. And this is actually a really fascinating site, even if you're not that interested in winter severity. If you just want to look at winter in your area, you can actually Google this and in real time look at what the winter severity is ranked in your area at that time. So you could log on today and you'd see it. This is a screenshot I took from this site when I first gave this webinar a while ago. And what we end up seeing is kind of where we are. So this was on February 3rd, right here, and we were in a moderate winter severity. So this winter severity index gives a number, and that sort of quantifies how harsh that winter was. And so that's what I'm going to use for the rest of this talk. Additionally, what I wanted to mention is I've been using the term severe and extreme winters. When I'm using those terms, like I said, that's not my subjective assessment. That's how these winters are being classified based on this winter severity index. So when we look at deer density in our area, and in particular look at how deer populations in our area change, what we see is a pretty strong relationship between winter severity and the annual percent change in deer density, or in other words, the growth rate. So the y-axis here is essentially the growth rate of the deer population and how much it grew or decreased. This flat line here at 0, any point above that line means that the deer population grew, and any point below that line means that the deer population decreased. And you'll probably notice a pretty obvious pattern here, which is during mild winters, which are on this end of the spectrum, deer populations always increased during our study, or have always increased. During severe winters, deer populations have always decreased during our study. So over the past 10 years, we could track just rough changes in deer populations just if we knew what the winter severity index was. What's interesting is we see the same exact relationship when we track the changes in deer hunter success from one year to the next. So in this graph on the y-axis is the annual percent change in hunter success rates. And so what that means, any point above 0 means that hunters were more successful that year than they were the previous year. So this is relative to the previous year. Similarly, anything below this line means that hunters were less successful than they were the previous year. And again, we see a fairly consistent pattern. When we have mild winters, hunter success rates are almost always higher than they were the previous year. They almost always go up. And when we have harsh winters, they almost always go down, which is on this side right here. So at least in our small area, the Greater Voyageurs ecosystem, there seems to be some pretty strong relationships between winter severity and deer populations and deer hunter success rates, and really changes in deer hunter success rates. So that really got us interested then in expanding this and looking to see if these patterns, in particular between changes in deer hunter success rate, were unique to our area or were really indicative of a large-scale pattern. So, like I said, I contacted the Minnesota DNR, got all of their old hunting records, and basically waded through all of that to compile hunter success rates in northern Minnesota for the past 4 decades, and track that through time. So when we look at how deer hunting success has changed for the past 40 years, this is what we see. On the y-axis, again, is annual percent change in hunter success. So again, if it's above 0, hunting got better than the previous year, and if it's below 0, hunting got worse than the previous year. And so we see some kind of interesting patterns here, which I'll talk about in a little bit. We can also plot and examine the patterns in winter severity during the same 4-decade period of time. And I'm going to put a dashed line here. This dashed line represents the average winter severity during this period of time. And what you're going to see is a pretty interesting pattern, which is that in the 80s to 90s, we had quite a few few severe winters here, but also quite a few mild ones. Then starting in the 1990s, late 1990s, all the way to 2007, all of the winters were super mild for the most part, or just average. But then after about 2007, what we start to see is we start getting a lot more severe winters, and they're becoming a lot more frequent. And we don't have a string of really mild winters during this period of time. So this graph here then just overlays these two sort of graphs on top of one another. So we have winter severity in the yellow, and then we have the annual percent change in deer hunter success rates in the purple. And this is going to look like a lot right now, at least it does to me. But there's a pattern I want you to see here, is when we overlay these two on top of one another, you almost see this yo-yoing effect. That in essence, whenever you see winter severity go up, you almost always see hunter success go down, and vice versa. whenever hunter success goes, or winter severity goes down, we almost always see increases in hunter success rates. And that pattern has held true pretty much for the past 4 decades. So there seems to be a real relationship here between the change in hunter success rates from one year to the next and winter severity. So now what I'm going to do is take this data and I'm going to look at it linearly, like we did in the greater Voyageurs ecosystem. And when you do that, this is what you see. So on the y-axis, again, is the annual percent change in hunter success rates, and on the x-axis is winter severity. And you'll notice the same pattern we observed in the greater Voyageurs ecosystem holds for all of northeastern Minnesota as well, and holds for even longer period of time of 4 decades. And that pattern is this. When we have severe winters, like we have right here, hunter success rates are almost always worse than they were the previous year. And when we have mild winters, hunter success rates are almost always better than they were the previous year. And importantly, this isn't just saying that hunter success is better in mild winters or worse after severe winters. It's saying that the magnitude of how much better those seasons were is also dependent on winter severity. In other words, the milder your winter, the more successful hunters are relative to the previous year than they would otherwise be. And the more severe the winter, the worse hunting is going to be compared to the previous year. Now, what's important to note is in Minnesota in particular, there's been changes between regulations in terms of buck harvests and doe harvests through time. So we did look at that. This graph here that I just showed, this is showing overall harvest, right? And we see this pattern. But if we just look at the buck harvest in Minnesota, we see the same exact pattern as well. So it really doesn't matter if we look at the overall harvest or the doe harvest, or the buck harvest, we see the same trend through time. Now I'm going to go back to this pattern in hunter success rate and how that's changed through time. And what I want to show are a couple really distinctive patterns. So the first pattern, not distinctive patterns, distinctive periods in time. So the first is from 1997 all the way here to 2007. And what we notice is during this time, hunter success rate climbed pretty considerably and remained at some of the highest levels that there really have been in the past 4 decades. And again, this was that period of time when Minnesota was sort of the glory days of deer hunting in northern Minnesota. That's what everybody sort of remembers as being, there's a lot of deer, people were really successful hunting. And then we see this period of time starting in 2007 where we basically just had this long-term decline in hunter success rates. And now people are obviously frustrated at how poor the deer hunting is, especially relative to the glory days. And what's really interesting is we can start to understand why we see those patterns just by looking at winter severity. So again, we're going back here. This graph shows winter severity on the y-axis through time. And again, we'll put these 2 periods of time on this map. And what we see is that during that period of time from 1997 to 2008, winter severity was low that whole time. There was not a single severe winter for a decade during that period of time. And during that time, hunter success increased and reached some of its highest levels. What we see is that, and I should clarify, so 0 out of 10 winters were severe. Now, if we look at the 15 years after that, which is when deer hunting has declined, what we've actually observed is that 9 out of 15 winters have been severe. So they've been above average winters. They've been sort of long winters with persistent snow cover. And so we can see that right here, where we have a lot more winters above this dashed line than we do below it. And so what does that do with deer hunter success rate? Well, we're actually just going to show this because I think this is probably one of the easiest ways to see the effects that these severe winters have actually had on deer hunting success. So starting in 1997, we see deer hunting success increasing, and none of these are severe winters. But then we see severe winters starting in 2008. And what we can see is every time we have a severe winter, there's a decrease in deer hunter success rate. So there's a severe winter right there. Deer hunter success goes down. And again, the reason hunter success is going down is because deer populations are decreasing. So hunter success goes down. Then we have another severe winter. Hunter success goes down. We get a mild winter. Deer hunter success increases because the deer population bumps up. Then we have a decline. another severe winter decline, another severe winter decline. We reached some of the lowest, actually the lowest hunter success rate the past 4 decades in 2014. Then we have a string of 3 mild winters. And what happens? The deer hunting success rates increase until 2017 and 18. And then we have a severe winter and we see a decline, another severe winter decline. And then the population actually bumps up a little bit right here, but then we have another severe winter and a decline, and then another severe winter, and it stays pretty much flat. So we can really track this pretty precipitous decline in deer hunter success rate just to the prevalence of severe winters in northern Minnesota. Now, lest you think this pattern is unique to Minnesota, I really started to get interested in wondering, is this happening in other places as well, where we can actually examine percent change in deer hunter success rate and winter severity. So this is data that the folks at the Michigan Department of Natural Resources shared with me, where I was able then to take that and calculate the annual percent change in deer hunter success rates across the UP of Michigan, where they obviously have wolf populations. And again, we see the same pattern that we saw in the northeastern Minnesota. Again, when there's mild winters, like here, deer hunting almost always improves over the previous year. And then when there's harsh winters, then almost always declines. So that holds for a 25-year pattern in the UP of Michigan. And then I got interested thinking about, well, what about northwestern Ontario, right across the border from us? We see essentially the same pattern there as well. That as time goes on, when you have severe winters, deer hunting always gets worse from the previous year, and when we have mild winters, it almost always gets better, like we see here. So, when we look at the data from northeastern Minnesota over a 40-year period, UP of Michigan over a 25-year period, and northwestern Ontario over an 18-year period, what we find out, if we kind of combine all of that information, we obviously see the same pattern in all of these areas. But what we also find out is that after a severe or extreme winter, which here is a winter severity index of greater than 2,400, hunting success the following year only increased 4% of the time. So essentially, hunting success based on all of this data, hunters never were more successful pretty much after a severe or extreme winter. They were almost always less successful the following year. After sort of a high, moderate to sort of borderline severe winter, what we see is that hunting success increased by about 40% of the time, which means that 60% of the time, hunting success either kind of stayed the same from the previous year or decreased. So even in sort of that borderline sort of winter severity, it still wasn't that great for deer hunting. By contrast, though, after mild to moderate winters, which are values less than 2,000, hunting success increased 90% of the time. So the vast majority of time after a mild winter, there were increases in deer hunter success rates. Now, we actually had some really interesting data from our study looking at wolf deer dynamics that kind of ties into this theme of winter severity and deer hunter success rates and deer populations. So in the winter of 2023, 2024, we had the mildest winter on record in northern Minnesota. And luckily, during that time, we were actually actively studying the predation behavior of wolves in our area. So this yielded some really interesting insights into wolf deer dynamics during this time. And what we found from this study is that the big findings were that during this mild winter, wolves were unable to kill enough deer to meet their basic caloric needs. So what we did is we studied GPS collared wolves. We found all of their kills, and then we were able to sort of take those kills and estimate how much biomass were these wolves actually obtaining from killing those deer, and then also what were they obtaining from scavenging other food sources. So a wolf in our area generally needs about 2.3 kilograms per day to sort of meet their basic energetic demands. If they're getting less than that, they're really losing body weight, and if they're getting more than that, they're putting on body weight. During this mild winter, our estimates were that wolves got about 1.5 to 2 kilograms per day during the winter, which includes food from scavenging. And so what that indicates is that during this really mild winter, most wolves actually lost body weight during that winter because wolves were not able to find enough vulnerable deer to meet their energetic demands. Now, in terms of predation levels, what we found during that mild winter is that the average wolf in the greater Voyageurs ecosystem during the biological year of 2023 to 2024, which I should note the biological year goes from April of 23 to April of 24. During that sort of biological year, we estimated wolves killed between 4.7 to 6.2 deer per wolf across that whole calendar year. Using that, that would mean that wolves killed roughly 15 to 20% of the deer population in the greater Voyageurs ecosystem that winter. And you might see that and say, well, that's pretty clear evidence that wolves must be having a pretty big impact on deer populations because that's a lot of the deer population. But that's what's really important when we think about the impact of predation is we have to consider the biology and ecology of the prey species, and that's obviously going to dictate what level of impact predation of that magnitude is going to have. So when we think about white-tailed deer, and what we know about white-tailed deer, which I'll talk about in a second, we actually concluded after seeing a predation rate of that level, 15 to 20% of the population, we actually concluded that that likely would have very little impact on the deer population in the area. And the reason why is that there's been a lot of work to understand essentially how many deer have to be killed to cause deer populations to stabilize or actually be reduced. And a lot of these studies are in areas where you have more deer than are wanted. And so there's been work to understand how many do we have to kill to cause these populations to actually go down. And what those studies have found out is that you have to kill somewhere around 25 to 40% of the female deer of the does if you actually want to cause those populations to stabilize or to decline. So you have to kill a lot of deer. And that's why obviously getting rid of deer where they're not wanted is such a challenge, is because deer are very productive species in the right circumstances. Most does in a deer population are going to be bred. Most are going to have fawns the next year. The average deer probably actually has more than a fawn because some have twins. And so deer can increase very quickly given the right circumstances. And so as a result, if you actually want to decrease those populations, you have to kill quite a bit of the female deer. Additionally, work has found that you have to kill a lot of bucks to really impact populations because bucks are not that important on a biological level to the population because one buck can inseminate many does. And so some estimates even said that you'd have to kill 75% of the bucks for there to actually be a noticeable impact on the population the following year. But the point is, deer populations can withstand really high levels of predation, harvest, etc., and still remain the same or increase. So we wrote a scientific paper, and in that paper, we concluded, based on our estimates, that the deer population the following year would likely go up or stay about the same. And at that time, we didn't have our deer population data for the following year yet. So we wrote that just based on what was known about deer and what we knew about the levels of wolf predation. And so what we ended up finding out the following year is, as we had written in this peer-reviewed publication, the deer population, per our estimates, increased by almost 11% in 2024 compared to the previous year, despite 15 to 20% of the deer population being eaten by wolves. Now, you might say that's really convenient. You predicted this would be the case, and you go collect the data and it confirms your prediction. How do we know you're not just sort of rigging the data? Well, the interesting thing is there's another way we can assess this, which is we could look at how did deer hunters do in the area in that year compared to the previous year. And what we see is when we look at deer hunter success rates is hunter success in our area for bucks in the fall of 2024 increased by 11.6%. So the increase in hunter success almost matched our increase in the deer population that we measured at the same time. So both of these indicate that the deer population definitely increased probably around 10 to 11%, even after that winter with that level of wolf predation. Now, the reason that study is really informative is that if wolves are the primary driver of deer population change, and not winters, if wolves are the drivers, then predation should have been really high in 2023, 2024, regardless of winter conditions. So winter conditions should just make really high wolf predation even higher. But instead, that's not what we observed. We didn't see really high levels of wolf predation when we were absent of winter conditions. The other thing worth noting is that we would also have anticipated in this winter to see really high predation levels if wolves were the primary driver of deer populations because in that winter we had really high wolf densities still coming out of those two really severe winters, and we had really low deer density. So it was sort of like the perfect scenario for wolves to exert this very high level of predation and really impact that deer population. Yet, despite that, we don't see that. We actually saw the opposite, where the deer population actually increased despite the fact that we had a really high density wolf population during that winter. Now, I didn't get to all of the details about this study, but if you want to read more about it, you can go on our website. Like I said, this is a peer-reviewed scientific article that you can access there, and the PDF is on our website if you want to read more about that work. Now, what's also very interesting is what we saw this past fall. So, what I was just telling you is basically the data from 2 falls ago as deer hunting success rate increased. And what we see in fall of 2025, after another mild winter, is yet again a pretty substantial increase in the deer harvest. So, the DNR report said this year that one of the areas in Minnesota with the largest increase in deer harvest was the northeastern part of the state, where harvest was up 14%. And that's just overall harvest. That isn't hunter success rates, which will probably be even higher than 14%. But those numbers haven't been publicly released yet. So again, we're seeing evidence these past couple winters that despite there being obviously still a dense wolf population, that the number of deer in the landscape is increasing. So all of this data provides, in our opinion, very strong quantitative evidence that winters are the primary driver of deer population change. And there remains very little data to suggest that wolves are the primary driver of deer or even a large secondary driver of deer population change. Another really important driver of deer populations that's a bit harder to quantify, but nonetheless is very important, is habitat. And habitat's really important for deer, particularly in winter, because in areas where there's severe winters, deer need cover to basically get out of the deep snow. So deer in northern climates like northern Minnesota, the Upper Peninsula of Michigan, Ontario, northern Ontario, they need conifer cover where they can shelter in because under that conifer cover, there's a lot less snow that builds up because a lot of it's held up by the conifers. And so it's easier for deer to move around, and deer save a lot of energy in those forests relative to having to move in areas where there aren't conifers. Because where there's not conifers, there's deeper snow, which means there's higher energetic costs. So conifer cover, importantly, is really associated with old forests. That's where you get conifer cover. You don't really get conifer cover in our area in young forests. Now, the reason that's important is because there's been substantial changes in the habitat of northern Minnesota and many areas over the past couple decades. So I want to dive in a little bit about what we know about sort of what kinds of habitats deer need during the winter time, and then kind of look at where are things at right now in northern Minnesota. So first, I'm going to talk about some studies, and I know understanding how deer, what they eat during the winters and how they move isn't quite as exciting as predation, but I think it's really interesting and very fundamental to understanding what deer need to actually persist during winter. So this is a study that was done, and what they concluded during winter, and highlighted the need of conifer cover, is that most natural winter browse foods are poorly digested by deer even though most nutritious of winter browse species are used to a surprisingly low extent. In many winter situations, it would cost the animal more energy to get up from its bed and forage for food than it would be able to obtain from that food. This is particularly true where deep snow and wind increase energy demands. So, in essence, what deer really are looking for in the winter is basically a place to hunker down and basically starve it out, or at least try to last and persist as long as they can. And that's because, particularly in severe winters, the cost to move around and go after food isn't worth it. They just can't get enough energy from it to justify it. And that fits in well with research that was done in Minnesota, in which these authors concluded that increased use of dense conifers by deer, where snow depths are shallower, but food is less abundant, suggests a survival adaptation heavily dependent on energy conservation. So winters are about conserving energy, not about foraging extensively. This is another study in another northern climate, not in northern Minnesota, in which they concluded during restrictive snow depths, deer increased their use of cover providing stands and did not browse in regenerating stands. Wintering deer consistently avoided aspen. And that's really a valuable insight because in northern Minnesota, there's a lot of logging, as I'll talk about in a bit, and the number one food that comes back, and the number one, or not number one food, number one tree that comes back in a lot of these cuts, and that's being, selected for, are aspens. So aspens are used for making pulpwood, and so that's the most dominant tree species. But this indicates that while deer like eating aspens during certain times of the year, in the winter time, that aspen really doesn't matter so much to them because they're spending all of their time in areas where there's shelter and cover from snow. Here is that same study. They concluded that we recommend that mature mixed wood stands be recognized as an important part of winter habitat for deer. We underscore their importance for wintering deer because they allow them to access shelter and browse simultaneously. So mature mixed wood stands means old forests, older forests that have a mixture of obviously the conifers that provide the shelter and then younger forage that fill in when trees fall over and there's gaps in the canopy, etc., that allow deer to forage without having to really leave the shelter of that cover. In the Upper Peninsula of Michigan, what they actually found is that large expanses of deciduous cover, which are generally aspens, in the landscape surrounding the patch of interest, which are conifer forests, may be the primary constraint to use by deer of what might otherwise be high quality winter habitat. So, what they're saying is by sort of clearing the landscape and turning it all into deciduous forest and only having a little patch or even a big patch of conifer forest, if that's all by itself and isolated, deer might not use that because there's not enough habitat connected to it. So that conifer patch might actually be decent habitat, but there's not connected to enough other good habitats to be useful. And then in Alberta, northern Alberta, they concluded that deer occurred most frequently with intermediate levels of conifers. And this is just a little graph showing here where were they most likely to occur, from basically, occurrence all the way up to about 80% down to 30% here. What they found is peak occurrence of deer occurred when about 40 to 50% of the forest was conifer. So the reason I bring up all of these studies that highlight the value of conifers is because that is the habitat type that is disappearing through time in Minnesota and has been disappearing for several years now. This is a quote from the Star Tribune. They said in 2012, 30% of aspen on state forests, and that means aspen forests, were estimated to be 50 years old. Those are old aspens where you start getting conifers coming up into the sort of canopy, and those forests are just starting to become maybe good winter deer habitat because they're starting to become conifers for cover. So 30% of the aspens forests were 50 years and older. Today it's in the 6% range. So that basically means there's very few stands on a state forest where you have old aspen stands where you also have those conifers coming in. So in other words, the amount of conifer has been decreasing even since 2012, and that's because there's been an increase, or not an increase, a decrease in the average rotation time. So forests are cut on average every 40 to 45 years, which ensures that there's aspens being taken, but it doesn't allow the regeneration of conifers and ever allow that forest to actually become good deer habitat in terms of winter cover. There was an article about this very issue in the Minnesota Deer Hunters Association magazine entitled "Where Have All the Deer Yards Gone?" And deer yards, if you're not familiar, are these areas with conifer forests that deer congregate in the winter to basically get out of the snow. And these deer yards have been slowly either disappearing in areas or being logged and not regenerating back. And so this is a habitat that's also declining. In that article, which was written by a former DNR wildlife manager in northern Minnesota, it says, intensive forest management has changed the winter landscape. The deer herd no longer has high quality winter cover options. Under this forest management regime, older forests will not exist on the landscape in most hunting areas. This is not a wolf issue, it is a forest management issue. And behind it, you can see the kinds of logging or intensive forest management that he's talking about, where basically it's essentially clear cut with the few small trees that are left, but most of the times it's a pure clear cut. Here's another quote from an article that was in Outdoor News. Um, and it says the current statewide planning process for timber harvests can wash out the needs of a particular species, he, Tim Quincer, a retired DNR forest wildlife coordinator, said, citing lost winter cover for deer in northern Minnesota where it's needed most. The effects of logging activity, Quincer points out, can last 40, 50, 60 years. The losses are hard to recover from. And again, right behind is just a photo I took out in the field of what most like timber harvests in our area look like. And you can see these don't leave conifers or a lot of places for deer to shelter in during harsh winters. This is another quote from a Star Tribune article a couple years ago by Jeff Lightfoot, who is a DNR deer habitat specialist. He said, wolves have always been there. When I hunted deer permit areas 118 and 119, which is our area, beginning in 1980, wolves were there as they are now. What's changed is habitat. We had a mix of older and younger aspen with balsam fir as a component. Now you mainly see young aspen with no conifer component. What's left of good thermal cover got smaller and smaller, and as those areas shrunk, deer became more vulnerable to wolves. So, in other words, during these severe winters, deer just don't have places to get away from the winter, and then they're more susceptible to predation, is what he's suggesting. What he's talking about in terms of forests not having conifer components, you can see this is a photo I took during our aerial beaver surveys. This is an area that got logged, and then there's some obviously other logged forest that's a bit older. And what you see is virtually no conifer trees in here. It's just aspens, and sort of a sea of aspen as far as you can see. This is another quote from a DNR wildlife manager, a bit more blunt, where they said wildlife management is being sacrificed for timber harvest. Mike Schrag, a biologist at Fond du Lac, stated, I wish deer hunters would see habitat sorry, my thing's in the way here. See habitat and its effects on deer the same way they see wolf tracks, he said. I wish they held county and state foresters to the same standards they hold wildlife managers. And so I wanted to talk a little bit about what would happen in terms of if we just stopped logging. What would the landscape look like? And then how does that connect into how we think about habitat for deer? And so one of the good ways to think about what would that landscape look like without logging is to go to places where there's not been logging for a long time and see what you actually see in those landscapes. So a good place to look in our area is Voyageurs National Park, where there hasn't been logging in most of it for at least 70 years, 100 years, something like that. And so Voyageurs gives us a peek into what the habitat, what the forest would want to be without any disturbance and without any logging. So this photo here is an aerial image off of Google Imagery, and this just shows what the landscape looks like. And what you see here, all this green, these are all conifers that are scattered throughout the forest. And you see a lot of green in that aerial imagery because you have a lot of mixed forests. When you get up in an airplane, this is what the habitat in Voyageurs looks like. You have lots of conifers interspersed with older aspens like you have here, but there's a real mix of conifers and aspens. Here's another example. We see large contiguous patches of conifers and then also large patches of deciduous trees as well. This is another example. Again, lots of conifers in this forest and then obviously some aspen as well. When we go outside of the park, though, and look at what that landscape looks like, it looks completely different. This is a aerial imagery from just outside of the park here, and what you can see is that a lot of this area has been basically just totally cleared. We do see little patches of some conifers here, but even those patches are getting logged around, or at least parts of those are getting logged as well. And then you have whole areas, as we see here, where there's just no conifers. And these are big areas. This map across is maybe about, I would say, 4 or 5 miles maybe. So these are large tracts of land that we're talking about. Here's another example in our study area. Again, most of the forest we see throughout here is aspen forest, and we get little patches of some conifers scattered throughout. But then again, even here we have, this was a bog, and a big area here is just cleared. Same thing we have down here. Here's another example. This is a very large area right here. And again, we have little pockets of conifers, but then we just have tons of aspen with very few conifers in them. And just another example here as well in the middle of our area where, again, we don't see a lot of green in here. We see a lot of just kind of brownish gray, and that's because there's no conifers. Now, what this looks like from the air is this. These are all photos I've taken during our aerial beaver surveys. You can see there's just no conifers in a lot of these areas. And we do get little pockets here, but there's lots of this forest, many, many long areas where there's just not any suitable cover for deer in the winter. Here's another example. Again, not many conifers in here at all. And so if you're a deer in the wintertime and you need cover to kind of get out of the elements, where do you go in a landscape like this? You either have to accept living kind of subpar habitat, or you have to leave that area. But this is what most of the area looks like. So there's not a lot of places to go to. Here's another example, little pockets of conifers, but mainly aspens. Another example here as well. And then another example, same sort of thing, right? Where we see just lots of aspens right here. Now, where do the deer go? Like I said, a lot of deer have to then yard up. They have to go to a place where there's a lot of conifers. And there are deer yards in northern Minnesota that are outside of national parks or protected places. We have a couple in our area. This is one of them. Now, the thing I want you to notice is when you look at this imagery, this is outside of the park, but nonetheless, what do we see? It's just dark green. Almost all of it's dark green. That's because there's a lot of cedar in this image, and spruce and other coniferous species. So that's what deer want. This is where they want to go in the wintertime. But this is the very landscape that deer need the most in the winter that's disappearing. And you can actually see in this map it disappearing as it's getting logged here. And once particularly cedar is logged, it doesn't really come back in Minnesota. It doesn't regenerate. So as these deer yards are chipped away at and logged at, those are habitats that are likely not going to improve. They're not going to get better for deer in the long haul. So actually, as time's going on, these habitats are actually getting worse for deer. Another really big one of the biggest in the state, is the Elephant Lake Deer Yarding Complex, which is in the sort of southern part of our study area. And where that complex is should be pretty obvious by looking at this map. It's just this big chunk of green right here. And you can see around it, everything's been logged. There's not nearly that much conifer, but here you have a big contiguous patch of conifer. And that's where the deer want to go. And again, when you zoom in, you can just tell it's going to be good winter deer habitat because it's so green, because it's all cedars and other conifers. So there's little evidence right now that wolves are to blame for recent lower hunting success. And one thing that's important to note is that while there's no evidence that wolves are to blame, there's lots of reasons to think that habitat has decreased substantially. And we often hear a lot of people thinking that we need to have a wolf hunting season, and we're not saying you can't have a wolf hunting season, but it's likely going to do very little to increase deer populations. But we have other aspects which are habitat management, and we have things going on right now where every year thousands of acres of habitat that is approaching being good deer habitat, they're being cleared, and this is happening year in, year out, and there's virtually no one's yelling about that really, and we think that that's something people really need to think about. If you want to see more deer in northern Minnesota, that's something that needs to be addressed, because without that, the habitat is not going to get better, which is going to probably reduce deer's ability to weather these severe winters and also potentially evade wolves. Oops. So what is important here, though, is we do want to clarify this isn't saying that wolves have no impact on deer, that there's not any measurable impact on deer ever. It's saying that there's not very much evidence to indicate that wolves are a driver of deer population change in any meaningful way, and that whatever impacts wolves might have are likely quite small. And again, one of the reasons we think that when wolves could potentially have a little bit of an impact are instances like these severe winters that I talked about a little bit ago. During these severe winters, we had high wolf densities, and obviously deer densities were pretty low. And this was the winter we did that predation study, and we found that wolves killed 15 to 20% of the deer population. And we did see that the deer population did increase by 10% the next year. What we aren't able to deduce or tell is to what extent that deer population might have increased if wolves weren't on the landscape. Could it have been 15%, maybe 20%? It's possible that after these severe winter weathers, that these sort of lagged high wolf densities could potentially slow the rate at which deer populations can increase. Again, that doesn't provide any evidence that wolves are actually causing deer populations to decrease. It just might impact the speed at which they can increase after some of these severe weather events. Okay, so now we're going to kind of pivot a little bit. We're going to get into the subject of, will wolf hunting and trapping improve deer hunting? And we're going to look at this because this is often proposed as a potential solution for increasing the deer harvest. And I've obviously already talked about sort of what we see in terms of the relationship between wolves and deer. And obviously, our perspective based on that data is that there's little evidence to suggest that hunting and trapping are likely going to increase deer populations in a meaningful way. But nonetheless, I think it's instead of just trusting, that that's our assessments legitimate, like let's look at the information here. And so we're going to look at some of this data and what we know about wolf hunting and trapping on wolf populations, so we can really try to understand what impact would a recreational hunting and trapping season in Minnesota actually have on deer. And a great place to start for this discussion is looking at wolf hunting and trapping seasons in Minnesota from 2012 to 2014. So wolves were removed from the endangered species list for a couple of years, and there were 3 hunting and trapping seasons. And so we can see, was there an impact, a positive impact on deer hunting during that time? So like I said, there's 3 consecutive seasons. In the first one, 413 wolves were killed. The next one, 238 wolves were killed. And then the next one, 264 wolves were killed via hunting and trapping. Now, what's important is you have to factor in, when we're thinking about this on a population level, the wolves that were also killed during that same year for depredations in the state. So in the state, wildlife services, if there's depredations on livestock, will go out and remove the problem animals. And so we have to add those into kind of the total number of wolves killed in the state during that year to try to understand what was sort of the population level effect of the hunting plus the depredations. And so when we do that, in 2012 to 2013, in the state, there were 628 wolves killed via hunting and trapping and depredations, which was about 24% of the population. So 1 out of every about 4 wolves in the state was either killed by hunting and trapping or by wildlife services for killing livestock. The next year, it was 333 wolves, which is about 12% of the population. In the following year, it was 436 wolves, which is about 16% of the population. So now we can actually track this on how deer hunting success in northern Minnesota changed. So this first year, 628 wolves were killed, so 24% of the wolf population. And what happened to deer hunter success? It actually decreased from about 33% to about 25%. So there's an 8% decline in hunter success despite 630 wolves being killed. The next year, another 333 wolves were killed, and it declined from about 25% to below 15%. And then there was the next year, 436 wolves killed, then we saw a little increase in deer hunter success rates. Now, what is important to point out, which is really interesting, is that the lowest hunter success rate in the past 13 years, and actually the past 4 decades, so since 1985, the lowest hunter success rate during that time occurred during the 3rd year of wolf hunting and trapping. So it's very hard to square that finding with the notion that a recreational hunting and trapping season is going to somehow boost deer hunting and deer populations in the state. Because if it really was the sort of proper way to turn deer hunting around and deer harvests around, we should have seen some evidence of that, especially given some of the rates of wolf killing that were going on during those years. But we don't see that. Now, what's really important to note is that despite hunting and trapping during those years, Minnesota's wolf population actually remained quite stable. So this is a graph from the Minnesota Department of Natural Resources Wolf Report that they do every year. And those hunting seasons were 2013 to 2015. And initially, you look at these population estimates, and it looks like they're lower than they were after and before, which would seem to suggest that hunting actually caused these populations to be lower. But the problem is, you can't look at that. It's not quite representative of where things were because when you have a hunting and trapping season, that is going to happen right before those populations are going to be estimated. And so, in essence, you have to add those individuals that were killed during those seasons back into the population if you really want to know, like, what would the population have been like if there wasn't a hunting and trapping season during that time. And what we see is that that population would have actually been pretty much on par with where it has been over the past 10 to 13 years. If there wasn't a hunting and trapping season. So in other words, the population in Minnesota remained fairly stable. And there's actually work that showed this. This is a paper looking at the recent trends in the survival and mortality of wolves in Minnesota. And what that study concluded is we did not observe evidence that survival was markedly reduced during years when a public harvest of wolves or public harvest was allowed on wolves. And if you don't see a difference in survival of wolves, then you're not going to really see a difference in population change, which is essentially what was documented. Now, there's another way we can look at this as well. We sort of have a quasi-experimental setup in northern Minnesota, at least in our area, because in Minnesota we haven't really had wolf hunting and trapping seasons most of the past 15 years or 17 years. But right across the border in Ontario, they have hunting and trapping of wolves, and that's been going on for a very long time. During the deer hunting season, I believe it's deer hunters are allowed to shoot up to 2 wolves at a time. And then there's a trap line system in Ontario where trappers are allowed to harvest. I don't think there's a limit on how many wolves they're allowed to harvest off of their trap lines. There's actually a trapper. We've had several wolves that we've collared go into Canada and get legally trapped. There's actually a trapper up in kind of this area that I talked to a couple years ago who caught one of our collared wolves. And he said that the year before he had caught and killed 35 wolves. And the year that he caught the collared wolf, I think he said he was at 20 wolves he had already killed by early January. So in some areas, there's pretty extensive trapping of wolves occurring in these areas. Now, the other great thing, though, about Ontario is they keep track of their deer hunting data the same way Minnesota does. So they have these different management units, and they record the number of hunters and the number of deer harvested. And they've been doing that for the past 17 years. And so we can actually compare what did deer hunting look like in Ontario, where there was wolf hunting and trapping, and outside outside of Ontario and in northern Minnesota, where there wasn't any. And notably, these areas have very similar habitats, very similar weather, similar predator and prey communities, similar amounts of logging and things like that. So there's not a lot of big landscape level differences between these two areas. So when we look at hunter success rates between our area in north central Minnesota, in and around the greater Voyageurs ecosystem, and then that area of northwestern Ontario, this is what we see. Basically, for the past 17 years, these deer hunter success rates in both of these areas have basically been tracking one another. They've been basically following the same patterns through time. When one goes down, the other goes down. When one goes up, the other goes up, and vice versa. So they show the same patterns. And why do they show the same patterns? It's likely because winter severity is ultimately what's driving changes in deer densities. And so that winter severity is going to affect that part of Ontario the same way it will our area in Minnesota, and that's going to cause the same reaction in the deer population. And so these patterns are almost certainly a reflection of the changes in deer density. Now, over the past 17 years, if we look at the average deer hunter success rate in northwestern Ontario, and then where there's wolf hunting and trapping, and then the greater Voyageurs ecosystem area here, what we see is that in the GVE, the average hunting success rate during this time has been 0.252 deer per hunter. And in Ontario, it's 0.257 deer per hunter. So in essence, the hunter success rates have been virtually identical over almost 2 decades in these areas, despite radically different approaches to wolf management. And so again, it's very hard to make sense of these patterns if wolf hunting and trapping is such a solution for increasing deer populations, increasing deer harvests. It's hard to explain why you don't see considerably higher deer harvests in Ontario than you do in Minnesota. So, why doesn't wolf hunting and trapping do anything for deer? Well, the first explanation, which is the one we've obviously suggested we think is the case, is that wolves are not the primary factor driving deer population change. And so, if wolves aren't the factor causing deer populations to change, you can kill as many wolves as you want. It's not going to ultimately change what's really going on because you're not really fixing the main factor that's causing deer populations to go up or down. Now, let's say you think that's total nonsense, you don't buy it, etc. Even if we could show conclusively that wolves were the driving factor of deer populations, wolf populations are very resilient to hunting and trapping, in the same way deer populations are very resilient to predation and hunting as well. And why are wolves really resilient? It's because, as I talked about earlier, wolf population size is driven by the amount of prey on the landscape. So if you don't change the amount of food on the landscape, you're not going to ultimately change the number of wolves on that landscape unless you kill wolves at a very high rate. So when you kill wolves, be it hunting, trapping, other reasons, you briefly drop that population below sort of the carrying capacity of that landscape. But what that means is that the surviving wolves now have a lot more resources available to them than they would otherwise because there's fewer wolves around. They're competing with fewer wolves. And because they have more resources, that means they get more food. And because they have more food, that allows the population to compensate for those losses via a variety of different mechanisms, including differences or increased reproduction or pup survival, delayed dispersal, and things like that. To kind of illustrate this whole process, I came up with this really crappy graphic that hopefully will illustrate kind of this premise. So let's assume in this graphic that this dashed white line is the sort of carrying capacity. That's the number of wolves that could be on the landscape given the amount of deer around. And so let's say without a hunting and trapping season, the wolf population kind of fluctuates around that natural sort of carrying capacity. And you kind of have these natural fluctuations. Now, let's say you implement a hunting and trapping season. And once you do so, you're going to kill a lot of wolves, and it's going to drop that population down temporarily to here. But that population is very quickly going to pop back up to that natural carrying capacity because that's what the landscape can support. And so once you knock them down here, it's only going to take to the next spring when the wolves have more pups, and that population is quickly going to be right back up where it started. And so you can then kill the wolves again, it'll come down a little bit, but then it's going to pop back up right back to that natural sort of carrying capacity. And then let's say you stop the hunting and trapping season, that wolf population then will start to just fluctuate again a bit more naturally around that carrying capacity. So the only way that you change this dynamic really long term is if you change carrying capacity. And the only way to change carrying capacity is to reduce the amount of food on the landscape. And that often is not obviously a popular solution because that means reducing a lot of the game species that a lot of people want more of. So, to put this just a bit more bluntly and a bit differently, to cause wolf populations to decrease, you really need to kill a lot of wolves. And that's really what's needed if you want to induce substantial population declines. And so we can actually look at some of the evidence here, and there's been work on this topic to try to understand what percent of wolf populations would you actually need to kill to cause those populations to go down. Here's a great excerpt, though, and we're going to start with some work by Dave Meach, kind of looking at what the effect of hunting and trapping is on wolf populations. So this is an excerpt from an article he wrote in 2017, and in it he states, the states, Idaho, Montana, and Wyoming, where wolves were delisted, allowed regulated public wolf harvesting. Some states tried to reduce their wolf populations through public take. However, most took fewer wolves than the annual increment from reproduction, so some even liberalized their regulations. So, despite killing wolves, they weren't killing enough to kind of overcome the amount wolves are reproducing every year. So, they liberalized their regulations. And he goes on to say, still, as anticipated, the states found it very difficult to reduce their wolf populations. Montana's population of at least 497 wolves in 2008, for example, included at least 536 in 2015 after 8 years of increasingly liberal harvesting regulations. And that's a great little segue into this. So in 2025, Dave Meach wrote that article in 2017. 2025, 8 years later, after 14 years of wolf hunting and trapping in the state, what was going on in Montana was a lot of legislation that was being proposed to basically liberalize hunting and trapping even further to try to get rid of or at least decrease the number of wolves in the state because they weren't being successful through recreational hunting and trapping. And I actually think this article put it best. This is from one of these articles, and it says both bills, which are these bills to increase or liberalize hunting and trapping regulations, both bills are supported by the Montana Trappers Association. Quote, these bills are a product of the inability of the state to reduce the population of wolves as directed by Bill 314 in 2023. So, again, despite the hunting and trapping, they still, in Montana, were not able to decrease that population in a meaningful way. In fact, the population almost seemed to have gone up a little bit. In Montana, they're I think it's Fisheries, Wildlife, and Parks. They actually released in their wolf management report that they estimated that they needed a human-caused mortality rate of greater than 27% to cause a decline in wolf population. So if they killed 27% of the wolf population every year, that would actually just result in a stable wolf population. It wouldn't change from year to year. And that estimate is not too dissimilar from other estimates that have examined this. So there was a meta-analysis done on this topic of basically, how much mortality can wolf populations withstand before they start declining. And what that paper found is that you need to kill greater than 22 to 25% of wolf populations to initiate population declines. And it notes that some estimates even suggest that's closer to 30%. Or sorry, that isn't noted in that manuscript. I'm saying that's what other papers have found, is that you might need to get close to 30% to cause these population declines. The state of Idaho is another great place to really look at to try to understand sort of how many wolves need to be killed to cause population declines, because Idaho recently has tried to reduce their wolf population pretty vigorously, and until recently they've had very little effect in doing so. So in 2021, because they couldn't reduce their wolf population meaningfully, the state liberalized harvest. And they basically, turn the regulations into an unlimited harvest by pretty much any means possible. And they also provided reimbursement for killing wolves, which is effectively a bounty, sort of a financial incentive to killing wolves. And the reason they did this was because based on their management plan, which they published in 2023, they concluded that in 2019 to 2021, 516 wolves died annually, a mortality rate of approximately 33%, yet annual reproduction during those years appeared to have replaced mortality, resulting in a stable population. So despite the fact that 1 out of every 3 wolves was dying every year, the population still basically remained unchanged year after year. They then went on to conclude, to reduce wolf populations, wolf mortality may need to be increased to 37% of the population annually for 6 years. So you have to basically kill 4 out of every 10 wolves every year for 6 years to cause the population to start declining. And importantly, you can't just do that for 6 years and then let off the gas and it'll stay there. That wolf population, the moment you stop killing wolves at that rate, is going to start increasing pretty substantially once again, because again, if you don't change the amount of food on the landscape, you're not going to change the natural level that population wants to gravitate towards. So for the past couple of years, that's basically where Idaho's sort of wolf mortality rate has been. And they're starting to see some small wolf population declines. Here's a population graph that they released that I got off of a Idaho Fish and Game Commission meeting presentation. They were kind of looking at two different population methods to estimate wolf population size. But the main takeaway here is that generally speaking, populations were remaining pretty stable through 2021. And then even since 2021, these populations have declined. But it's been a fairly gradual decline, despite the fact that almost 40% of the population is being killed every year. So again, the big takeaway is you need to kill a lot of wolves to induce substantial declines in wolf populations. So that's not to say that you can't cause populations to decline, but you need to kill quite a few. And I should note this obviously doesn't apply to very small, isolated wolf populations. We're talking about larger wolf populations like you have in Minnesota or places like Idaho, etc. So then let's look at wolf management in Minnesota. Right now, wolves are a threatened species and protected by the Endangered Species Act. There's indications that wolves might be delisted sometime soon, in which case they would be management would be returned to the state of Minnesota. And then the question is, how is the state going to manage the wolf population? Well, the guidelines for how the state will think about managing the wolf population are laid out in Minnesota's wolf management plan. And their wolf management plan, you can go online and find it. It's publicly available. We had no involvement in developing that plan, but anyone can read it and see what it has to say. And in that management plan, they state that their goals are to maintain a well-connected and resilient wolf population, maintain a population comparable to recent estimates, that wolf harvest, if there is one, there's no guarantee that there will be one, wolf harvest will not cause long-term statewide population declines. And so then they laid out potential levels of hunting and trapping that would be considered based on where the population is at. And so the population over the past handful of years has been in this 2,200 to 3,000 range, which means that they would consider a hunting and trapping level potentially between the 10 to 20% range. And again, you'll notice these considerations in terms of the percent of the population is sort of in line with the work that I was just talking about of kind of what level would impact wolf populations negatively, and these numbers are obviously well below the rates that would be needed to impact those populations negatively, which is why they can both suggest that there could be a harvest that doesn't cause long-term statewide population decline. So the notion that there could be a hunting and trapping season and that is connected to population declines is not an accurate thing. You can have both stable populations or increasing populations and also still have hunting and trapping. Again, these aren't values-based statements. They're just sort of the biological realities of sort of wolf management and wolf populations. So based on the state's wolf management plan, as well as all of the evidence that is out there on wolves and deer hunting, there's nothing to suggest that wolf management is going to really change things in northern Minnesota, and it will almost certainly do very little to change wolf-deer dynamics in the greater Voyageurs ecosystem or northern Minnesota as a whole, or even other parts of Minnesota. So I would also say too that hunting and trapping wolves to help deer is like squeezing a stress ball. It makes some people feel better, but it doesn't really change anything. So it makes some people feel like they're doing something, like they're having an effect, but really they're not having really any meaningful effect at all. It just makes them feel like there's something changing. It makes them feel a bit better about it. Now, lest you think that that's all well and good, but we should still try it just to see what would happen. There actually was a really fascinating experiment that was done in the 1990s in Quebec, where they actually started to do experimental wolf removals and killing wolves at very high rates to basically see what the impact would be on deer populations. And so what they did in this study is they set up a couple of areas, and in these areas, one of them they killed 40% of the wolves annually for 3 years. And in the other area, they killed 71% of the wolves in that area for 3 years. And then they compared that to control areas where they did not kill wolves at these really high rates. And they wanted to see basically how did deer hunting success rates change in these different areas based on wolf management. This was their conclusion. They said the harvest of bucks was not affected by the wolf reduction. We do not recommend wolf reduction as a management tool in the current context, as deer numbers increased markedly even where no control was applied as a consequence of mild winters. So even killing 71% of the wolf population didn't yield a better harvest of bucks in that area. And again, this is a study in a very different part of the world that's finding the same patterns that we're seeing here in northern Minnesota and in other areas. So there's a variety of pieces of data that all point to the same conclusion. The other thing that's really interesting is in this study, what they also found was in spite of this, which is killing 71% of wolves, wolf numbers had recovered to previous levels 8 months later, and the number of packs had even increased. And they figured that was because they killed wolves in this, like, I forgot how big of an area, 400 square kilometers or something. But what they figured is that the moment they reduced that density, there was a bunch of other wolves that just came in from other places because you created this void where resources are really abundant relative to the amount of wolves. And so wolves quickly immigrated into that area, and that population was back up to where it was before they did it. So again, unless you want to kill wolves on a large scale at very high rates year after year, it's very difficult to get their numbers down. So, like I said, this talk, and hopefully this is apparent, is not a statement on wolf hunting and trapping, or federal delisting, or any of these sort of topics. Rather, it's just an assessment of the scientific information on these topics and what we can glean and learn from them. And this is where it's really important to separate out science from values, because often when we're talking about wolves in general, but also wolf deer dynamics, these two get conflated. We hear on both sides of from both sides sort of on the debate, both people who want wolf management, people who don't want any wolf management, that the science supports their perspective. The science is on their side. And many say people start by saying the science says X, Y, or Z. But in reality, the science doesn't support any perspective on this topic. They don't support that we should have wolf management or that we shouldn't ever shoot a wolf. All science does is it tells us the way the natural world works and what impacts our actions have on the natural world. It tells us how the world works. It doesn't tell us how we should behave or the sorts of things we should do. It just tells us what would happen if we did a certain action. So I want to kind of illustrate this of what the science actually does tell us. So what the science indicates is that wolves can be hunted and trapped sustainably. That is pretty clear, and there's really not a lot to suggest that's not a factual statement. Hunting and trapping seasons in Minnesota would have little to no impact on the wolf population in Minnesota, given the levels laid out in the wolf management plan. And this would be the case unless done at very high levels. There's hunting and trapping will do little to decrease wolf populations. That's a scientific assessment. Wolf populations, if left alone, if there's no hunting or trapping, they are not going to proliferate out of control. They are going to regulate themselves based on prey abundance. So the notion that we have to manage them to keep their populations in check with prey populations is just simply not factual either. Science also says that wolves do not appear to be driving changes in deer populations in northern Minnesota. And it also says hunting and trapping wolves will do little to increase deer populations and thereby deer hunting success rates. It also says that changing forestry practices would almost certainly create better deer habitat for deer and almost certainly increase the deer population's ability to persist through severe winters. So the science can tell us all of these things, but it doesn't tell us what we ought to do. That is ultimately where values come in. Values are what inform us how we take that information and then the decisions we make based off of that. And so we think wolf management, like the management and conservation of all natural resources, should reflect what society values and what society wants. In a democratic society, natural resources are the people's resources. And so as a result, whatever people want, whatever people value, should ultimately be how those resources are managed, whether that means there's wolf hunting and trapping or there's not wolf hunting and trapping. But we do not comment on these values-based decisions because they're outside of the purview of science. And whatever our individual perspectives are, they're no more important than anyone listening to this. And so, at a minimum, we think and we hope that directing this conversation more to the value side and less to the argument about what the science says would just generally be beneficial so we can get to the real issues that are sort of the crux of these discussions about wolf management. And with that, I want to give a big thanks to the 10,600 private donors who've supported our project throughout our project's existence. Their support has been tremendous, and now the majority of the funding we get on an annual basis comes largely through private donors. So we really appreciate that support. And if you value our work and our outreach and sort of our perspective on topics like this, like I said, our project is funded solely by donations, where we get no funding via state agencies or federal agencies or anything like that. We don't have a guaranteed budget from the University of Minnesota, so we really are funded by donations, grants, and any other funds we can generate. So we'd appreciate any support. If you're willing to, you can go to our website, voyagerswolfproject.org/donate. And then there's several other organizations that support our work. The Minnesota Environment and Natural the Minnesota Environment and Natural Resources Trust Fund is a really big one that supported our work for a very long time. We have other ones, including the Voyageurs Conservancy, University of Minnesota, Van Soon Foundation, International Wolf Center, and many others. And with that, I will take any questions that folks have. Remember, please use the Q&A function. That would be very helpful because I'm not going to be I'm not going to be checking out the chat here. So, okay, so let's see here. Let's see. Someone says hunting into my 90s is a personal goal. So cool. It is pretty impressive. I hope I'm in as good a shape as they are when I'm 90 years old. Um, Okay, why are the number of hunters declining? Well, that's a really good question, and this is something people have been examining and trying to understand for quite a while because this has been going on. This isn't obviously a recent phenomenon. There's the main factor, it seems, is sort of an aging demographic. Hunters, the average age of hunters is going up through time, and then that's not being sort of replaced by young hunters at the same rates. And so you have this sort of shift in the demographic and sort of just a general decline in interest in hunting. And that's what obviously there's been a lot of push by state agencies to try to increase hunter recruitment and hunter retention because obviously a lot of these agencies depend on funding from license sales and things like that. So that's what a lot of the discussion is, like that paper in Wisconsin that I referred to. A lot of their main takeaway is this is going to cause some real challenges or this is going to cause some real challenges for the state because of how that's going to impact their ability to manage deer populations and also in terms of funding. So it'll be very interesting to see what the future decade, 2 decades really looks like. This next question says, in VNP, where you have more conifers, are deer less impacted by severe winters? So that's a great question. And one thing I should note that I actually forgot to mention, which I was meaning to, is that Voyageurs National Park has a lot more conifers, but in some sense, Voyageurs isn't also ideal habitat because it's kind of on the other end of the spectrum. You still need some disturbed habitats to provide particularly good forage during the summertime for deer. And so, like I was showing in some of the studies, the ideal thing is when you have 40-50% of the landscape's conifer and the rest is maybe some young browse and things like that. So Voyageurs on the one end because all their forests are quite old and you have very few that are very young because there's no logging and there's not a lot of natural disturbance. There's not a lot of forest fires which would have, traditionally created a lot of young habitats and things like that. So Voyageurs also isn't prime deer habitat necessarily either. There's probably like a mix between, we basically need a balance between what Voyageurs is like and what you're seeing outside of the park. That ultimately would probably give a better sort of a mixture of those conifer forests and the young forests that deer also need at other times of the year for good forage. And I should note too, we haven't examined deer survival in Voyageurs National Park. So I don't know the answer about that, but we have looked at deer densities, and deer densities in the park are not any higher than they are outside of the park. Again, that's likely because it's not ideal deer habitat either. Um, Here's another question. Uh, the first one says, I was wondering how you determine the number of deer and wolf populations in a given area with reasonable accuracy, and how large is the typical area in which this is done? So that's a good, we'll start there and then I'll get to the second part of this question. So I'll start with deer populations. So we estimate deer populations using pellet transects. So these are transects. This is used for a lot of ungulate species. And we do a bunch of these in the springtime where you go around and you hike the same transect every year and you count the number of deer pellets. And then there's ways to take that and come up with a deer density estimate. What we would say the pellet counts are generally a very good way to track changes or trends in the populations. The actual number of deer is a bit more challenging. And so what we would say is, and for us, we're more interested in the trend in the data, how the population grows from year to year, than whether or not the number of deer in our landscape is 1.5 deer per square kilometer versus 1.9. Certainly, obviously, we hope we're getting both, but what's more important is the trend and that it's done consistently year after year because that provides us with an index that is reliable for tracking the deer population through time. And the reason why we think that those estimates are pretty good representations is because they track deer hunter success rates so closely that there's such a strong relationship there. And the pattern that we see, not only do deer populations track hunter success rates, but we see the same pattern in deer population growth rates in regards to severe winters as we see in the changes in hunter success rates. So there's lots of other ways of looking at that estimate, where we can say we have pretty good confidence that that's actually showing the actual changes in deer density through time pretty well. Now, regarding wolf populations, in terms of reasonable accuracy, so the way that we estimate wolf populations is we have over 400 remote cameras out in the wintertime. We generally in our study area have had anywhere between 19 to 22 packs in our area. And that means we have about 20 cameras in each pack territory on average during the winter. And the goal there is to basically get as many observations of those packs as we possibly can, so that we not only can count the number of wolves in each pack, but we actually know who each wolf in that pack is. So we want to be able to identify the breeding individuals, the pups, the subordinate wolves. And if you watch a lot of our videos on our social media and see sort of the commentary, and a lot of those we actually comment who those individuals are because we know who they are because we've seen them so often. During our winters, we on average see two or more members from a given wolf pack once every 2 to 3 days. So we're seeing these wolves all the time on camera, which allows us to get really good population estimates. And I would even say I hesitate to even say it's an estimate because it's really a census because we are observing all the wolves in all the packs. And we've set up our approach so that we aren't really guessing that the number of wolves, we're basically counting them and arriving at it. If you go on our website, we have descriptions of all of our annual reports from the past handful of years, and you can read in those reports all the data we collect, how we do it, and then there's a summary on each pack, and it's got a detailed summary of all the individuals in each pack, all the data we've collected. So our goal is to have really good metrics on the wolf population and prey populations every year so that we can really understand these changes through time and that we're not just getting sort of statistical sampling noise when we do these comparisons. We're actually getting really good measures of these populations through time. And in terms of how large our area is a little under 1,000 square miles or 2,300 square kilometers. Here's another one. And then the second part of that one. Which prey animals other than deer play an important role in the diets of wolves in our area, if any? And do those other prey animals affect the wolf population very much from year to year? So that's a really good question. So the other really important prey animal I would say would be beavers, as I mentioned. Like I said, beavers on average for the typical wolf in our area during the ice-free season, which is going to be April-ish to sometime in November, beavers will be about 30 to 40% of all the biomass wolves obtain via predation during that time, which is quite sizable when you think about that. That means essentially deer are contributing 50 to 60% somewhere, or sorry, 60 or 70% of those diets. So beavers are a really large aspect of this. There is not a lot of indication that we've seen that beavers are driving population trends. And part of that's because beaver populations have remained really stable through time. So there's not a lot of change from year to year in beaver populations. But I would say it's almost certainty, and we're working on publishing this data, that the number of wolves that we have in this study area or in our area in general, and probably in other parts of northern Minnesota, are much higher densities than they would be if there weren't beavers. Because when wolves can get 30 to 40% of their food during the summer, which is really the lean season. So summer is what's really going to constrict how many wolves can be on the landscape, because that's when wolves are struggling the most to get food. So if you then add another prey source which can get 30 to 40% of the food that wolves can get, in theory that means it seems like you could have maybe 30% more wolves on the landscape because you have a lot more food to support those wolves. Um, so that's something we're looking into right now. And we do have some, we think, good data to suggest that beavers are causing just the overall population to be 30% higher than it would be, which is probably why, like where we're at in northern Minnesota, we actually have lower deer densities than other parts in Minnesota and Wisconsin and Michigan, and yet we actually have higher wolf densities. And the reason likely is because of that role that beaver's playing. A lot of these other areas do not have the beaver densities that we have, and wolves don't rely on beavers as extensively in those environments. Now, if you go north into Ontario, you start to get a lot of places, or Manitoba, Quebec, you start getting places that have high beaver densities like we have, and I bet those areas probably see similar patterns. Um, okay. When was the Quebec study done with the two areas? That was a 1992 study, so I don't remember what years they did that in per se. But I know that it was in 1992 was when it was published. And it was by the author, the last name of the first author was Potvin. So it's Potvin et al. 1992. Has there been studies on deer movement ecology and hunter success rate? If wolves are on the landscape pushing deer around, would that make deer hunting more difficult for people? Asking as a lazy hunter myself. Um, so there's been that question of how do wolves influence, let's say, yeah, hunter success rates in terms of like pushing deer around. My feeling. So I don't know if there's been any specific studies where they've looked at like, okay, there's wolves moving that have a collar on, and then there's been deer moving, and how does the wolf cause those deer to move? But what I can say is that there have been deer collared in our area in the past by the DNR, and they've shared their data with us, so we've been able to look at how deer are sort of on the landscape and how they're moving. And then we've also actually this winter, about a month ago, we started um, collaring deer in our area as well as sort of a different part of our study as well. And all of this seems to indicate that wolves, or deer, I should say, are undoubtedly encountering wolves all the time on the landscape. There was a study by Meach and other colleagues in the Ely area that estimated that deer were likely encountering a wolf every 5 days in northern Minnesota. And our work would suggest that as well, because wolves are constantly moving. So the idea that wolves are moving deer around is very unlikely on a large scale. I mean, it doesn't mean certainly that wolves couldn't chase a deer for a little bit, but the notion that like a wolf shows up and then all the deer just leave is just really doesn't have support, because if a deer had to move every single time it ran into a wolf, it would be expending tons of energy doing that. What really happens most likely is wolves see a deer and actually don't even go after it because they realize that deer's not vulnerable, or they go after it for a very short period. Deer goes a little bit, wolf gives up, and then the wolf goes back to doing what it does until it finds a deer that it actually thinks is vulnerable. And there have been observations like that by folks and the researchers in the Ely area showing deer just kind of standing there and wolves approaching and then just leaving. We've caught some of these things on trail cameras where a wolf gives a deer a little chase and then just gives up. So all that to say, there's a lot of evidence to indicate that deer are encountering wolves all the time, and that the idea that wolves are impacting deer hunting that way is, it certainly doesn't mean that it couldn't happen where wolves couldn't bump a deer or some deer around or chase after them for a little bit. But on a large scale, it seems very unlikely that that's causing much of an impact on deer hunting. Okay. If you laid population controls naturally with deer and wolves, would it then be similar to the lynx hair cycles? That is a very good question, and we don't know because really we are now have one of the longest data sets that's been collected, to our knowledge, of wolf density and deer density and how those are changing through time. Obviously, the lynx hair cycles are something that were collected over many long periods of time. I can't remember how long of a time period that was. So the hope is if we can keep our work going long enough that we would be able to examine this over decades and we might start to see are there cycles? What drives those patterns? I mean, that would be super fascinating. So we just don't know right now. It's certainly conceivable. The challenge is, unlike lynx and hare cycles, is winter weather obviously playing the role it does you know, could really disrupt those cycles, right? Like we saw as I talked about, in 7 years of the study, wolves and deer were following each other, and then all of a sudden things just kind of get out of whack after we have this sort of these winter conditions. So it's like maybe if you had stable weather conditions and the only thing that changed were just the deer and wolf populations, maybe you'd see some more clear cycling. So just don't know. That would actually be a great thing to look at in an environment which unfortunately doesn't really exist right now, where you have wolves in an area where there aren't harsh winters, right? Where you have mild winters. Let's say places like, the like southern US where, wolves were at one time. That would be a fascinating way to look in those kinds of dynamics. Um, does forestry there use glyphosate to manage new aspen growth and newly conifer planted cut blocks? I'm not sure what they use, but I know they do spray when they do certain cuttings to promote certain species to grow back. I'm just not sure which one it would be or what chemicals they're using specifically. Someone said, you said you would need to kill a high percentage of wolf population for many years to impact the wolf population. Is it because of loss of habitat that wolves became an endangered species in many areas? The reason wolves became an endangered species in most areas is because they were basically eliminated from everywhere in the U.S., at least the contiguous U.S., except the northern chunk of Minnesota. And in that northern chunk of Minnesota, which is Voyageurs, we were one of the few places where wolves were never lost. That's basically the only place that they could persist, and they only persisted there likely because they were connected to Ontario. And if you go north from where we're at, the wolf population would be fairly robust because there's just not very many people and there's lots of land. So wolves were put on the list because of that, because in the late 1960s, 1970s, they basically weren't anywhere else. And then obviously as time's gone on, wolves have started to spread throughout these states and through much of the Great Lakes region and then also the Rocky Mountains. It really didn't have anything to do with the loss of habitat, and that's something that's valuable to remember. So people often think that wolves need certain kinds of habitats, dense forests, etc. But wolves are very adaptable species. They could easily live in cornfields, agriculturally dominated landscapes, even very urban, rural kind, or sorry, urban, suburban settings, if people didn't kill them. As long as there's food there for them, and in most of those areas where it's, cornfields or agriculture or where there's, suburban areas, there's lots of deer and other food available. The problem is the reason wolves don't live in a lot of those landscapes is that's where they're highly vulnerable to being killed, and so they can never get established because they end up getting killed. But if you look in places like Europe, you have wolves existing in areas like the Netherlands, Italy, and other environments like that where you have really, really high human population densities. And they have wolves in these areas that are essentially what we would consider effectively like suburban areas. But wolves are tolerated and managed a bit differently there. So wolves are like habitat is it would have to basically be a barren desert with no prey animals in it for it to be unsuitable habitat for wolves. Otherwise, wolves can live in just about any habitat, which is why they live in deserts, the Arctic, forests, plains, high mountainous regions. They can live in all these kinds of habitats as long as there's enough food. I think that right now are all the questions. Are there any other questions that folks have? I'll give a couple minutes here, or a minute or two if there's any other questions, and then otherwise we'll wrap it up. Okay, well, I'm not getting any other questions. So, oh, let's see here. Sorry, there's a couple more that just came in. My apologies. Um, there is some growing interest in Alberta looking at the link between glyphosate and CWD. It'd be interesting to look at deer CWD numbers and compare the results long term with areas that have low and high wolf populations. Is there any improvement in CWD? Luckily, right now, we do not have CWD in our area. The nearest it's been detected or area is about 2 hours south of us, near Grand Rapids, Minnesota. Hopefully, it stays that way, but we don't have it up here yet. Obviously, if it does make its way up here, it'll be something we'll be interested in trying to understand and look at, particularly as it pertains to wolf predation on deer. But it's not something we have right now, and so hopefully, it stays that way, ideally. Do you have any suggestions for grad study topics on wolf deer dynamics? Well, there's tons and tons of good questions to look at wolf deer dynamics. A lot of it, I think, just has to do with looking at, I think, population dynamics. And the challenges with wolves and deer, I think a lot of the really interesting questions require some really long data sets, or at least long-term data to look at trends in these populations. And those are obviously very challenging to come by. Um, so I don't have a lot of, at least off the top of my head, I do think there's ways that could be looked at to understand, let's say, some of the more behavioral components. Like I was just talking, there are estimates that wolves and deer are encountering one another quite a bit. But really getting some good data, let's say from GPS collared wolves, GPS collared deer, to really get some high resolution data on that, and also to understand what changes, let's say, a deer's encounter rate with wolves. Are they less likely to encounter wolves in certain habitats? Things like that. There's all sorts of these behavioral questions to try to understand both how wolves find deer and hunt them, and then also how do deer avoid predation or interact with wolves, and things like that. So I think there's endless topics in that regard. So, um, someone says, "Is it okay to share this presentation once we receive the link to the recording with others? I would love to share this information with the Alberta Trappers Association as well as our Alberta Fish and Wildlife." Absolutely. So I'm going to share this link. So this was the intention from the beginning, was to make this, to record this presentation, put on our social media and or on our YouTube channel, and then make it public. That was the goal because it's a free webinar for anybody. So yes, absolutely. I'm going to try to send this link out via to all the people who registered, and I'll send the link out hopefully tomorrow morning sometime, and you're welcome at that point to share it with whoever you want. So it'll be publicly available on YouTube. If for some reason you don't get the link tomorrow, just look for an email or just go to our YouTube channel, Voyageurs Wolf Project, on YouTube, and you should see it there at some point, hopefully in the morning tomorrow. Okay, since there's no other questions coming in, I think I'm going to wrap it up. Thank you, everybody, for your patience. And thank you for, yeah, being understanding of the whole Zoom link fiasco we had. And, anyways, like I said, this will be online sometime soon, or sometime tomorrow, I should say. And I'll be in touch. So thank you, everybody, and have a good night.